Hello, good evening. Can you guys hear me?
Yes, sir.
Okay, guys. So, do you have any questions or doubts in the last session related to motor interface and sensor interfacing with at Mega 16? This was the program which we did yesterday. So, any questions, any problems? Okay, that means no questions. So, let's go to the last topic of the AVR and then we will start the next controller, which is Arduino. So, now in this AVR, first of all, let's create a new design and pick at Mega 16, and then let's pick one alternator. So basically now we are doing AC component interfacing. AC component mean it may be a lamp, it may be the bulb, it may be any other AC operated device. So for now I'm considering one lamp. So let's pick lamp as well. And to operate this lamp, we have alternator. We have at Mega 16, and now we will take one more component called button, so that when the button is on, the lamp must be on. Or in other words, we can also say we are creating a small project of home automation where we have a button like sensor. So if the sensor is turned on, we have to turn on the lamp. And if the sensor is turned off, the lamp must be off. That means the program that if someone come inside in the room, the lights goes on automatically. And when someone go outside, then the lights must go off. So let's do button we picked up. Now we need one register as well, which is called pull down concept. We already know about the concept. So let's connect each and everything together. So we also know if we use alternator and lamp, which is basically our AC operating component, we need one more component here to operate the AC components, and that is called relay. So let's pick one relay. Let's pick one relay. Now let's drop the relay here and let's try to connect. So we are giving the signal from PC0 to this relay. Mostly I'm using PC0 in all the programs. That does not mean that you will not, that we will have to use PC only. We can use any port like PD, PA, PB. So it's completely your choice. Whichever you feel comfortable, you can connect that. Now we know it must be ground because we need to give the logic 5 volt to the first pin and the ground to the second pin to complete the path and to generate the electromagnetic fields as well. Now, as it's 12 volt, we have to change it to 5 volt because we are directly connecting it with controller. And then let's loop your lamp alternator and the switch of relay. So relay, which is called electromagnetic switch or a mechanical switch, where we give the electric supply, and due to which it get energy in the form of electromagnetic field and get magnetic properties as well. And due to that magnetic properties, the switch attracts towards the magnet. So it helps us to create or to break the path. So let's connect a button here, and we are connecting this button to port D7, or you can also connect it to port D0. Then we need to give the power to the other terminal of the button. So let's connect power here, and let's connect one register RES with this button, and let's connect ground as well. So this is the time to create the program for the same. We have connected one button at port D0, and one output at port C0. So I guess this is the P10 program, and 16 mean at mega 16, and it's always not mandatory to use at mega 16. Now let's do one thing. In this program, I'm not using at mega 16. Let's try to use another controller. Let's say if it is at mega 32. So almost if we see that mega 32 is same like at mega 16, we have same way PC0, PA0, PB0, PD1. So let's skip this one as well. Let's try with another one at mega 2560, 2560. It has more number of pins as compared to at mega 16. Here we have multiple ports like port A, B, C, D, E, F, G, H, I, J, K, L. So we have multiple pins available in this controller. So this time I'm using at mega 2560, and let's connect this relay to port F0, and port H0 I'm connecting the button. So here we need to select the IC 2560 so that it can compile and generate the hex file according to that. Now we have used two ports, port F for relay, that means the output port. So DDRF.
हाँ ये भी कर लेना चाहिए हाँ चंगड़ी से कंफर्म बटवाई तो ये पता नहीं जरूरी थोड़ी है स्ट्रिंग एडिट से तो
Okay, so I just connected one relay with port F0 and one input with port H0. The same we are now going to define in the program. DDRF equals to 0B, port as output, that means 11, 11, 11, 11. Or also we can write it 0xFF. Then DDR H equals to, the whole port is going to be the input one because it's connected with a button, and the input is defined using 0. That means if we write the code in binary, it must be 00000000, or if we write this in hex, it must be 0x00. Now let's come to the while loop, and here let's say int x equals to. So we have to mask, and to mask it, this time we have port H. So pin H and 0B 00000001, because we have used only one pin, which is port H0, and that is connected with your button. So we are not making it 0 by force. We are just asking to disable all the pins forcefully, like port H1 to port H6, 7. Simply now we have to start comparing. If x equals to 0b 00000001, that means the first button is on. And if the first button is on, we have to write the code to port F, which is 0b 00000001, or also we can write it 0x01. Let's close the loop and let's write another condition, which is else if x equals to 0b 00000000, or also we can write it 0x00. That means the whole port is 0, none of the button is on, or none of the pin is high. So port F equals to 0x00. That means we have to turn off the LED, or we have to turn off the relay. Now let's say let's build the code, build solution. So this time it's going to create the hex file according to atmega 2560, and let's try to run this. If you try to run the file of atmega 16 into the controller of 2560, it's not going to work, and vice versa. If you're going to write the code of 2560, atmega 16 is not going to accept it. So we have to select the controller whichever we are using in the hardware or in the simulation. So we have the program named P10. Let's select the hex file and play the circuit. So currently the lamp is off. Also, we need to modify a few more things, like this alternator must have amplitude of 220 volt, and this lamp must be of 220 volt because we are considering it as AC component. Now, if we play and turn on the button, we can see the relay is triggered, the switch is triggered and jump to the position of normally closed switch. Hence, the lamp is on because the path is completed for this. In the same way, if you do not want the output in this way, you can switch it to this pin. That means if the button is on, the lamp is going to be off. And if the button is off, the lamp is going to be on. So it's vice versa case. And same program, we can also change this in the program if we don't want to change the connections. Let's simply connect it here only at another point. Here we can change when the button is on, turn off the LED, and when the button is off, turn on the LED or relay, whatever we have on the output side. Simply let's go to this and play. So this time when the button is not on, we can see the lamp is on because relay is all automatically triggered as we are passing logic 1 to port F0 when button is off. And when the button is on, then port F0 is 0 and accordingly the relay is off, triggered to off. And now we know that this time we are using the relay of 5 volt, but what if we use the relay of 12 volt? Because this time if controller provides us any logic, it's not going to trigger because 5 volt is not enough for this 12 volt of relay. What next we can do, we can skip connecting the relay directly to controller. We will have to use one IC which is called ULN. I guess I already told you about ULN IC, and if not, then we can also try it with L293D. So I'll tell you both L293D. First I am using L293D. Let's give the logic to input 1 and corresponding we are getting the logic at output 1. Then this pin is permanently ground, so we not need to connect output 2 with the relay's second pin. Also, we need to connect this to ground. So either we can connect it here or also we can connect it here. It's completely your choice wherever you want to connect. Let's give the power to this IC L293D. So we need to connect two powers, one at pin number 16, which must have 5 volts, and one at pin number 8, which must have 12 volts. The reason for 12 volt is very simple because this is the external supply voltage which we have to pass to relay. And as we are using only one side of the relay, we have to connect enable 1 with your power, 5 volt source. And then if we go to play, the relay is triggered. And if I give the logic 0, the relay is triggered to off. That means the path is break. This happened because we changed the program last time. Now I'm doing it same as earlier. So when the switch is on, the relay must be on. And when the switch is off, the relay must be off. So let's build the whole code again and then go to Proteus, stop your circuit and replay. We not need to write the project file because it already has the access or the location of that hex file. Now, if we click play, if we click button, we are giving the logic 1 to port H0 and accordingly at port F0 we have logic 1 which is triggering the relay to on and the lamp is on. And if it is 0, the output is also 0. So this was with L293D IC. We did two cases here. The first was when the relay we have for 5 volt and the second one when relay we have for 12 volt. So in case of 5 volt, the L293D IC is not required, but in case of 12 volt, it is required. Now, as I said, we have one more IC that is ULN IC, which is called relay driver IC. Actually, this L293D is called motor driver IC. We can use it because it has same functionality, but this is not the actual IC which we should use with relay. So let's pick one ULN 2003A Now we know about it. Whatever logic we give at pin number 1B, it gives the logic corresponding to 1C, 2B to 2C, and in the same way 7B to 7C. So if suppose if I'm giving any logic to port port F0, that means 1B, we will get corresponding output at 1C. And then let's connect this common pin with 12 volt. But actually what's going to be happen if we run this circuit in this way? If the button is on, the relay is still not triggered, and if the button is off, the relay is still not triggered, although we are giving the 12 volt external supply voltage and a ULN IC, but still the output is not there, because we know in case of relay, if we give the logic 0 to input pin, if we give the logic 0 to input pin, it will make null logic at output side. And if we give the logic 1, it will make 0 at output side. So when we talk about L293D IC, in case of L293D IC, if we give the logic 1 at input side, that means input 1 pin, we get logic same 1 at output 1 pin. But in ULN, if you give logic 1, it makes it 0. And if you give logic 0, it makes it null. That means on the output side of the relay, we are never going to get logic 1. And at this pin of relay, we need logic 1. So we must delete this. And let's directly give the 12 volt from the source. But if we connect in this way, then it is not required. This is also not required. These things are also not required. Because if we play, we can see the relay is triggered and the lamp is on. That means why it's happening? Because we are giving direct 12 volt and the ground to the relay. We must not connect this ground directly. We will have to connect this one. So this time the relay first pin, positive pin has 12 volt, logic 1 permanently. But we are not giving the logic 0 permanently. That depends if 1C gets 0. And 1C gets 0 if 1B get 1. And 1B get 1 if you trigger or you turn on the button or the sensor. So let's turn on and we can see the relay is triggered. Let's turn off. Again, the relay is triggered and it's off and the lamp is off. So the guys, now we are done with almost 4 to 5 topics with at Mega 16, at Mega 2560, or in short AVR. Now we are going to switch to another controller. If you still have any questions, any doubts, you can ask me. Otherwise, I'm going to start that. I'll take like around 30 minutes of gap so that you can decide what to do. If you have any questions, you can ask. Okay, fine. If you do not have any doubts, let's start the new controller, which is Arduino. So now I'm going to create a new file, new design. And if I pick Arduino, I can see the Arduino Uno is there. Let's double click and drop it to the screen. Now, this Arduino, when I search in Proteus, I can easily find it. Even I do have more controllers of Arduino. I use the Uno one. We have Pro Mini, Nano Mini, Mega 1280 and Mega 2560. But in your case, if you installed it for very first time, you won't find this Arduino library in Proteus. So firstly, you have to copy this library. And how to do that? Let's go back to the folder which I shared with you guys. So going to technology and in embedded systems, do we have here or do we have here softwares, robotics soft, I guess I shared with you. I don't know the name of the folder. ES, yeah, got it. The name of the folder was ES. So let me search it first. Yeah. So in this folder, I shared total 4 files. You already installed these 2 files. Now you have to install this Arduino 1.6.13. You can also install the latest version of Arduino Uno, which you can download from the Arduino CC website, which is open source software. You not need to purchase any license. Then now let's copy the library file of Arduino into the Proteus library. How to do that? You have this folder, Arduino library for Proteus. There we have Arduino tep.lib file. Just simply copy this file, go to OS, go to program files, program file 86. Here we have a folder called Lab Center Electronics, and then we have Proteus 7, and then we have a library folder. So here you have to paste this file. I'm pasting it, and then it's asking me to replace the file because it already has Arduino library uh, pasted in this folder. In your case, if it is not there, you have to copy in this way, how I'm doing. So for now, let's skip it. And after doing this, you can open Proteus. Proteus must not be open while doing this, otherwise effects won't be available. Now, let's pick Arduino Uno, this controller. So now we have one question. I don't know about you guys, but yes, if I'm student like you guys and someone is giving me training or mentoring me about these things, I'll ask, what was the need of AVR if we are doing this Arduino controller? So first of all, I would like to clear you guys that Arduino is not any controller. It's a controller board. It's a controller board which has the controller at Mega 328p. So next time if someone asks you, you don't have to say I used Arduino controller. Actually, it's not controller. It's a board which is assembled with at Mega mean AVR controller and a few more ICs. So I'll give you one example to understand this clearly. I'll give you one example to understand this clearly. Suppose we have a problem that we want to turn on the light of the room when the switch is on or the sensor is on, and then we have to turn it off when the switch or the sensor is off. Recently, we just did that program using Atmega 16. So when we have to keep it on or keep it off, when we have to keep it on or keep it off using the sensor, it's going to work very easily because your AVR is capable to understand the logic in the form of 0 and 1. But when we talk about controlling the devices remotely, mean suppose you made this whole automation, your lights are turning on and turning off easily with the help of sensor. But now what I want, like sensor will turn on the lights automatically and sensor will also turn off the lights automatically. If what if I have to stay in my room? What if I have to stay in my room and I want the lights to turn off? Because we already applied the automation, and according to that automation, the lights are going to be turned off when the sensor is off. That means I need to go outside the room to turn off the lights. But when I want to sleep inside the room, the light must be off automatically. But according to the circuit, according to the program, it's going to be turned off only if I go outside. So that means with this automation, we also have to apply, the manual effects. And for those manual effects, and For those manual effects, we need to put a button. That means we have a process called manual plus automatic. Sometimes if we want to sleep and sensor is going to turn off the light when we go outside, we can use the manual switch to turn off the lights. Or otherwise, sometimes when the sensor is not working, we can control those lights manually. So wherever we apply automation, we have to put the option of manual as well. Now, if we put the manual switch and we put the sensors for automation, we can do it easily. There is no problem. And AVR is capable to do that part as well, because AVR can understand the digital logic. But now I'm putting one more situation here, and that is what? I have to sleep. I have to I have to turn on the switch, or I have to turn off the switch manually, but the switch is far away from my bed where I'm sleeping or where I want to sleep. That means I need to go to access the switch. And I can say like it's around 10 or 20 feet, but 10 or 20 feet are not too much. But we guys are so lazy and we do not want to do anything from our side. We want if we can turn off the lights or we can turn on the lights sitting on the bed only or sitting on the sofa only. So that time we can use our mobile phones to control these type of devices. That means if we are sending the logics from the phone, it must be delivered to the device. For that, we need a wireless connection. So suppose we are creating one Android application. We are creating one Android application or a iOS application or a web application through which we want to control that device. We will have to connect a modem. If we created one Android application, we have a GUI there. We have two buttons to on and off. We have to simply press the buttons on the mobile phone to keep your lights on and off or to keep any device on and off. But how to transmit the data? How the device is going to receive the data? How the AVR is going to receive the data? So for that purpose, I'm including the wireless connection starting with Bluetooth. So we have to connect one Bluetooth module with AVR controller, and our mobile phone already has the Bluetooth. That means my mobile phone is going to transmit the data to the Bluetooth of AVR through the Bluetooth of my mobile phone. So this is also like necessary to write the program to transmit and receive the data through Bluetooth. Now, what is the difficulty here? My mobile phone's Bluetooth is transmitting the data to AVR's Bluetooth. When we're doing it Bluetooth communication, they both are comfortable to understand the language of each other. But whenever the Bluetooth of AVR is transmitting the data to AVR controller, AVR is not capable to understand that. I'll repeat my words, what I said. When we are transmitting the data through our mobile phone's Bluetooth to AVR's Bluetooth, both are managing the transmitted and the received data by both the devices because they belong to same family. But once the Bluetooth of AVR is giving that data to controller is not capable to understand. And the reason being because AVR does not belong to same family. In the same way, Wi-Fi to Wi-Fi is easy, but Wi-Fi to AVR is quite difficult for AVR to understand. So in those places, we need to understand the whole library of Wi-Fi, the whole library of Bluetooth, the whole library of GSM module, the whole library of GPRS, or any other external peripheral which we are going to connect with AVR microcontroller. So this is like our task to understand each and every component's library now, which is going to be very difficult for us. Because if I generally tell you about the program of Bluetooth interfacing with AVR, it takes around 2 to 3 pages of our notebook. So that means whenever we want to connect any external peripheral with AVR microcontroller, we need to understand each and every command of that peripheral, and then we need to write that in the code. So this was the challenge faced by AVR that time. So what actually this Arduino did, they used the same controller. They used the same controller AVR, but they added one IC in the board which already has all the libraries of external peripherals. That means Arduino board is the combination of AVR controller and few more ICs, basically library IC, which already has the library of all other external peripherals, which we are going to connect with AVR. And it also giving us the option if any of the library is not available. Suppose we are going to connect one new device which is just launched in the market. We are just going to connect one external peripheral or a sensor which is just launched in the market. And Arduino hardware is already developed. Definitely they wouldn't be having this library. Definitely they wouldn't be having the understandings of that component. So they are giving us the option to import any library which we want. They are giving us the option to import any library which we want. So in the software of Arduino, which we are going to use is IDE, Integrated Development Environment. There we have an option of importing the library. So simply you can download the library from the Arduino software or any third party like Google or any other search engine like GitHub, Google, Geeks for Geeks. Many options are there. We have to simply download the library from external source and import into the software. So that's why we did Atmega 16 first. We did AVR first. We must have knowledge about AVR controller if we are going to create the program for Arduino. Now, Arduino is the product from Italy, which has many components available like AVR. AVR is available in 3 different families like Tiny, Mega, X Mega. And even in Mega family, we have Atmega 16, Atmega 8, Atmega 32, Atmega 1280, Atmega 2560, and many more. In the same way, Arduino also has multiple boards like Arduino Uno, Arduino Nano, Arduino Pro Mini, Arduino Mini, Arduino Wi-Fi, Arduino Robot, Arduino Pilot, and Arduino Nano. So Uno mean one in italic language. This was the very first board. This was the very first board designed by Arduino. So they named it as Uno, U-N-O. We are going to use the same now. So it has Atmega 328 IC, and here we have 4 ports, but we are allowed to use only 3 ports, port C0, port D, and port C, port D, and port B. And also here we are not going to write the program for any ports. We have to write the programs for the pins individually. So let's start understanding the pin diagram or the hardware architecture of this Arduino Uno. So the operating voltage of this Arduino Uno is up to 20 volt of DC. We can connect the adapter of maximum 20 volt of DC, but I recommend to use 12 volt of DC adapter with it. If you see this black colored connector, here we can connect the power adapter of 12 volt of DC. And if you don't want to connect the adapter, we can also connect the battery source to these pins. These pins are not visible in simulation, but in real time, the first pin is V input, then this pin is ground, then this pin is also ground, then this pin is 5 volt, and this pin is 3.3 volt. So you can connect the battery source at V input and ground. Then whenever you have to program this controller board, you can connect the USB cable to this gray colored port. If you connect the USB cable, your Arduino will get the supply of 5 volt because the USB ports of our computer provide 5 volt of supply. So if we connect the cable at gray colored port, that means our controller will get 5 volt of supply, and we can also get this 5 volt of supply from these pins like V input and ground. Then we have two more pins, 5 volt and 3 volt. There also we can get 5 volt and 3 volt respectively. And if you connect the 12 volt of adapter to this black color port, we can receive 12 volt of supply at V input and ground, then 5 volt and 3 volt at 5 volt and 3 volt pins respectively. So there are three ways to give the power to this Arduino board. Generally, if you are creating a project, if you are creating a product, we usually use the battery sources. But when you have to fix your device at one location, like to turn on the lights and to turn off the lights, that time you can use the power supply adapter as well, because that time the battery source is not required. Generally, we use the battery when we have to move the product, like a robot. Then if we see pin number 0 to pin number 13, total we have 14 digital input output pins, which we can use to read the logic in the form of 0 and 1, and also to write the logic in the form of 0 and 1. Pin number 0 to 13, we have 14 digital input output pins. In the same, we have 6 pins for analog write, pin number 3, 5, 6, 9, 10, 11. So what is digital write? Suppose you have to turn on the lights or you have to turn off the lights, you have to turn on the motors or you have to turn off the motors. Simply you have to give the logic 1 or 0, which is called digital logic. And in the same way, if you have a sensor which is giving you the logic 0, 1, if it reads something, it's giving you 1. If it does not read something, it's giving you 0. Again, we have a 0, 1 logic called digital read. But now, what is analog write? Suppose now you have to turn on the fan with the variable speed. Like when you feeling hot, the speed of the fan must be high, and when you're not feeling so hot, the speed of fan must be moderate, and when you are feeling cold, then your fan must be off. So sometimes we have to give the maximum speed to the fan. Sometimes we may need to give moderate speed, and sometimes we may need to give the lowest speed. That means we don't have to simply write 1 or 0. We don't have to simply write 5 volt or 0 volt. We have to vary the voltage so that it can vary the speed, it can vary the intensity of the lights as well. So whenever we have to write the logics in variable form, we have analog signals, and that is called analog write. For that, we have 6 pins, pin number 3, 5, 6, 9, 10, 11. Then last 6 pins, A0 to A5 on the left side, port C0 to port C5. These are to read the logic of analog. Again, those sensors which are not going to give you the logic of 0 and 1 simply. Suppose you have the temperature sensor, pressure sensor, where we know the signals are going to change every time. Like we know the temperature is not fixed for throughout the day, it changes at every instant of time. We can use these pins to read those kind of signals, which is also known as continuous signals. So that is it for the day. Now we will start the programming of this controller tomorrow. So meanwhile, if you have any questions or doubts, you can let me know in the group. Thank you so much. Have a great night. Bye-bye. Take care.